You know what you're getting in me. I founded the Shadow Robot Group back in 1987, and I led it for some time, and I'll tell you about that. But I think it's important to make it clear to you that I'm no longer the managing director of Shadow, which is Rich Walker, and maybe you meant to invite him, I'm not sure. 5 years ago, I said I want to get back to actually inventing robots rather than trying to run a company. Running a company is no fun at all, in my view, and certainly doesn't leave you any time or energy for anything creative at all, or very little creative at all. I was 65, and I said, look, I'm going to retire. I'm going to retire to doing what I really enjoy and really love, which is robotics. I actually believe robotics can save the world. I believe you guys can save the world. It's got the potential to do almost anything. And I must say that I found during my sort of 15 years of trying to run a bloody company, excuse my French, but it pulls you down. Just to go back to the start, what happened was this. I joined a company in 1982 called Intergalactic Robots. It's a great name. Only lasted a couple of years. I tried to persuade them to build a humanoid robot, but they were much more sensible and business-focused, so they stuck to something much humbler. But I started working on the ultimate humanoid robot, a biped, of course. During that time, that's the early 80s, I was looking for something that would act like a human muscle, because I wanted a humanoid body. And I came up with the idea of inflating a balloon inside a net glove, and that led on to the Shadow air muscles. It turned out I wasn't the first person to come up with this idea, and many people attribute it to McKibben in America, although he wasn't the first either. The more you track it, the more it goes back. The idea of an air muscle is that it does do something very similar to a human muscle in terms of it pulls, you just put air in it, and above all, it's compliant, it's soft. And there's a lot of talk now about series elastic actuators coming from America, and oh gosh, this great new thing. It actually does nothing more than an air muscle, and in my view is a lot more expensive and complicated. So, this will now hopefully run. This is the Shadow hand. Now, many of you, I hope, will have seen the Shadow hand. It's been, if you Google for robot company, we come up quite quickly, and the Shadow hand, say I, and I think unopposed, is the best hand in the world. At least it's got the most movements, the fullest and closest representation of a human hand. It actually has got 22 movements, the same number as a human hand, which no one else has attempted. They may have been right, I have to say. It's just extremely difficult to make something inside the human hand envelope that actually does all the movements of a human hand and have it not go wrong at all. So I think we had a bit of hubris there, and we might have done better if we had gone for something simpler. And so it started off in 1987 with me and people in the attic, and we started building a humanoid robot. We got one with legs which could almost walk but not quite in 1990, sometime in the 1990s. And then the Japanese started coming out with one after another of their fantastic walking robots, and we realised that with no budget, homemade sensors, homemade actuators, everything made out of wood, we couldn't really compete. So we switched to hands. And I started building, in the early 90s, a wooden humanoid-shaped anthropomorphic hand, and got as far as making it pick up a smooth-sided pint of beer, which at that point no one else in the world could do. So this then became a company in 1994, and now there's about 16 of us. We've got our premises in Islington. We're very much focused on the hand. Now, this is in a sense what I was wanting to get away from when I said that I wanted to take time off from running the company and go and invent actual robots. Because the problem is, you have a product like this, it keeps you going, it's your bread and butter, but it requires fantastic attention of all sorts, maintenance. This is the air muscle one, which was the first one. In some ways it's better because it's got this wonderful compliance that air muscles give you, which means it's very easy to do the sort of things you want to do in the home, in the domestic environment, in the unstructured world that I'm interested in. It's actually just easier than you think. You don't actually necessarily have to do very fast control loop software. This is done using a data glove. And the problem with data gloves is that there isn't commercially available a really good data glove with all 20 degrees of freedom, or 22, depending what you count. And this is something that we'd like to produce, but there's not many robot hands in the world that can do this kind of thing, playing around with a raw egg, playing around with a light bulb, and allowing something up close and personal, right? Don't forget that industrial robots still mostly, it is changing right now as we speak, always had to have a fence around them, or they would just stop if you approached them because you broke a light beam. It is inherent in air muscles that they are safe. And this is an air muscle arm that we've not sold many of, but again, it's gentle, it's soft, it's safe. It's not as precise as industrial robotics. And this is really the big question. And I notice now that in America, the new company, it was called Foundation Robotics, that's brought out Baxter, is talking the same language as we've been talking for years, as saying, well, we don't have the same sort of precision and repeatability as conventional industrial robots, but what we do have is safety and compliance, and it's something that you can work around. It can work with people. Now, in America, I'm just going to show you a bit about the air muscle. This is just the lovely way. Can you see all right, by the way? That's okay, is it? Yeah. The lovely way they behave, soft, gentle, fluid, able to do all sorts of movements, and quite powerful. That's a 6-inch nail on the right, and if you inflate it with a little air, it easily bends a 6-inch nail. No problems about that. We've built some very small ones at the top. That's about 30 millimeters long. And some very big ones. This is one that NASA asked us to build, and it's 8.7 meters long. And please don't ever ask us to build another one. It's an absolute nightmare. We've done sort of various odd things since about legged robotics. This was a test device that we built for Lego, but it got to nothing. And an American university, North Carolina, NCAT, asked us to do a leg with the same movements as a human so they could use it for experiments in myoelectric control. But we haven't done anything really since on humanoids, apart from the hand itself. And so what I really want to say today, and I hope we will discuss, is the future of robotics. Where does it lie? I've been saying humanoid for years and years and years. Oh, it's got to be humanoid because the environment is built for humans. Everything, the shelves, the doors, everything's built for humans. And second of all, we can crib the design. It's damn good design, whoever thought of it. And so let's borrow it. I have completely changed my view on this. Humanoids have got us nowhere in the 20, 30 years I've been involved in this. Frankly, it's pathetic. If I'd thought back in 1980 when I started that this is where we'd be, I must move on from this. This is all good fun, but that was the original hand, by the way. It's a bit out of order, really. if I'd thought that progress would be so pathetic in terms of robots that can come into your home and do stuff for you, I would have given up there and then. Now, we're at an interesting point now, because there's been a lot of very interesting work coming out of particularly America and Korea. Japan perhaps has, I'm not sure, but you feel as if Japan is not quite sure at the moment. But it's there. There's huge public wish and desire and love of robots. And America, I'm sure you've been following, partly because of the DARPA challenge, partly because of this amazing partnership between DARPA and Boston Dynamics, is producing very, very impressive stuff. The quadrupeds, a big dog, and the bipeds, Atlas, and the other one who follows Atlas. Very, very impressive. But hang on a minute. Sit in a train and take a journey through the industrial England and look down at the houses, row upon row of houses, and say, are these robots, what have they got to do with people, real people everywhere? Now, I'm 69. When I become too weak to look after myself, I do not want to go into an old people's home and have that experience. We all know about the demographic time bomb that is coming, and surely robots could help here. I think, well, everybody thinks they could. I can tell you that we're being, the local authorities are talking to us, all sorts of people are talking to us. There's all sorts of funded projects for care of the elderly. Now, I can't see Big Dog or the Atlas robot. I mean, please. I want cheap, safe, reliable. Can I go back to cheap again? Cheap. These things are just too expensive. Right from the beginning, they are just too expensive. I don't know. I have. If anyone knows what the Atlas robot cost, I'd be very interested, because I've never heard a figure put at it. But, and they will get cheaper, of course. They will get cheaper, but they're not going to get cheap enough. I can't see them if I look in the back streets of Sheffield and I think of all those old people there who need something that will really help. I don't think that the legged way forward is any good. I don't think the human or pseudo-human way forward is any good. You won't, if you even have a butler that can do everything, which is extremely difficult. It's still only one. Do you know how many things you do in a day? Do you know how many things a caregiver needs to do in a day? There is so much. Now, there is one area where I think robots have been very successful, and I have to admit that in the past I was a bit sceptical about them, a bit down on them, and that's industrial robotics. And they're all they're not really robots, they're just fixed machines going bang, 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 bang. Hang on a minute, they are really doing stuff, and they are reasonably priced. Now, we can learn from them, and we can also start, instead of sort of going, mimetic robotics is the way forward, we should follow nature. Let's just think from scratch. How would we get an old person out of the bed? How will we help them to the lavatory? How will we help them to look after themselves and live independently? And the answer is not going to be a Jeeves. It's going to be, you need to invent something new and clever. I'm sorry, I'm showing these a bit out of sequence, but they just give you a background of what Shadow's been doing. So, what happened was, I went off to the hills 5 years ago, literally up to Cumbria, and I started spending 4 or 5 months a year up there. And what I'm doing now is a 15-year plan for a robot home that I can live in forever. Okay? I don't want to have all these people pouring stuff down my throat and so on. I know that robots can do it, and what we just need to do is just to start afresh and not, as I say, not be led, as I see it, down the alley, the the sort of false friend of humanoid robotics. Thousands of people do brilliant gadgets, but what is needed is to integrate all those gadgets into something that works together and that an ordinary person can run as easily as their iPad, or in fact more easily than their iPad. And I want a system that's incredibly complicated, but which to the user, the complexity is hidden. And they don't have lots of things everywhere, but when they want to do something, they want to make a cup of tea, they want to pick up the kettle full of boiling water safely, a helping hand steadies them. Okay? That's what I want. So please help me do it.
Thank you so much, Richard. Professor Shanahan is actually a professor at Imperial. He's working on cognitive architecture in the Department of Computing, so hopefully he can say a few words about his research and his views on the future of robotics.
Okay, thank you. Actually, I was just asked to talk for 5 to 10 minutes about.
So was I. I apologise.
No, that's fine. That's fine. It's just that I'm afraid I'm not going to live up to your to the previous speaker, because I have no slides or videos or anything. So I'll just say a few words about my interests, really, and maybe a little bit of autobiography. I mean, it's really embarrassing to do that kind of thing.
Sorry, come and sit down.
Water in the seats of your picture.
Water, thank you.
Would you like someone in a bit?
Oh, right, okay, yes.
So I did my PhD in Cambridge way back in the 1980s, 1984 to 1987. And when I graduated, I was extremely interested in pursuing the grand sort of vision of artificial intelligence that I'd grown up with in science fiction books like I, Robot and so on. And that's what I really wanted to work on. I wanted to see how that kind of thing could be achieved. And at the time, the sort of really trendy area to work in, or not just trendy, but it seemed like the right area to work in, was what we now think of as good old-fashioned AI, or symbolic artificial intelligence. And that's what I worked in. So I worked in trying to understand knowledge representation, how we could build machines that represented knowledge of the world in a symbolic form, in sentences, and use procedures, logic-based procedures, to reason about those representations, and in order to perhaps converse with us, to give us advice, to decide what to do, and so on. So that was the area that I worked in. And in the back of my mind, I always knew that robots were the things that were the ultimate acid test for this sort of thing. But I got completely sidetracked into this whole symbolic AI thing. Now, in 1989, a roboticist, a very, very famous roboticist by the name of Rod Brooks, who many of you will have heard of, wrote a series of papers which really attacked this type of artificial intelligence, this type of AI, symbolic AI. And what he said was that there were many strands to his criticisms, but one of the central strands to his criticisms was that you needed to think about embodiment. We are embodied creatures, and our intelligence really derives from the way we interact with the physical world around us. And so he recommended abandoning all of this stuff about reasoning and logic and all that kind of thing, and went back to nature, really, started from the ground up and thought about how we can build simple robots that can actually get around in the environment and do simple things, because we were so far from being able to do that kind of thing in those days. And clearly nature has built our sophisticated cognition on that kind of ground, on basic sensory motor skills and the ability to just interact with our environment, manipulate things, get about, and so on. And and I had to admit that although I'd got very much into symbolic AI and knowledge representation, all that kind of thing, that he really did have a point. And of course, many people thought that he had a point, and he had a tremendous. Well, he caused really a revolution in AI and in cognitive science and in robotics. He's caused a kind of revival in robotics. So from that point on, there were many, many people who were thinking about how we can try to achieve AI from the ground up, recapitulating the route that nature took and starting off with simple robots that it can interact with their environments. So I was very impressed with that, and so I started working more in that kind of way. Still within the back of my mind, the vision of AI that I'd enjoyed, as a boy in science fiction films and books. So now, for a long time, what I did was I tried to adapt my previous expertise and experience with logic and knowledge representation to a robotics setting. So, my title is I'm Professor of Cognitive Robotics, which is about how you make smart robots, supposedly. And this phrase cognitive robotics is now used a bit more widely, but at that time it was really used to describe a little subfield, which was how you applied all of those knowledge representation techniques using logic and so on in an embodied setting with robots that move around. So these robots were meant to construct representations in logic of the world around them and reason about what to do next on the basis of these representations of the world. So it was really just taking that symbolic AI idea and putting it into robots. And for a while, which is certainly not what Rob Brooks was suggesting, because that's not the way nature did it. But for a while, it seemed to me that idea was going to fly, and I worked very hard on trying to adapt my previous research agenda to a slightly modified Brooks influenced agenda where robotics was central. And so I worked along those kinds of lines for about maybe 10 years or so, from about 1990 to about 2000 or thereabouts. But gradually I became more and more disillusioned with this approach and became actually more and more Brooksian in my outlook, and thinking we really needed to look to nature, because nobody was really getting terribly far with this approach to robotics, and all the people who seemed to take on Brooks's message ended up going back to just fiddling around with theorems in logic and so on, and then forgetting about the robotics applications and not really achieving terribly much. Meanwhile, some engineers who were taking a probabilistic approach to robotics were achieving great things in enabling a robot to just do basic navigation in the world. But I was really interested, ultimately, with that, the kind of iRobot vision in the back of my mind, ultimately interested in understanding cognition. So I had this Brooks sort of message in my mind that we need to do things from the bottom up, the way nature does. But I wasn't satisfied to just stay at ground level. I wanted to see how you could really get to cognition. Now, these cognitive robotics guys, as it was called at the time, were sort of starting in the middle, still trying to use logic, and but that didn't seem to be getting very far. So that's when I started becoming increasingly interested in trying to understand brains and trying to understand how cognition is realized in the brain. And that's still where I am now. And what I'm really interested in these days is trying to understand how the embodied brain enables sophisticated cognition. And this, of course, is a vastly difficult question, because you're really trying to understand the brain. But following the sort of Brooks recommendation that we should look to the same kind of time course that evolution followed to produce sophisticated cognition, then I'm interested in trying to understand simple animals, simple brains, and then gradually build up to more complicated brains embodied in robots. So that's the agenda. So when it comes to the technical details, what I'm actually doing technically, well, what I'm really interested in these days are a number of technical topics. And that's the kind of background. The technical topics that I'm interested in are things like brain connectivity, because brains are very complex networks of dynamical elements. I'm interested in spiking neurons and trying to represent how neurons behave, building networks of these spiking neurons and enabling them to control robots. And we're still a very long way off being able to take that kind of basic substrate of spiking neurons and turn it into something that can perform even the kind of simple cognition we see in say rats and pigeons. But that's the direction in which I want to move. So it's a very it's a kind of complementary agenda, I think, to yours, because it's not really applications that are driving my interests, but it's this hopelessly big question about the nature of cognition. And for me, robotics is a tool for trying to understand that.
So, thank you ever so much. Now we shall open the panel to questions. Does anyone have the first question? Yes?
To the speaker, what did NASA ask you to ask you for your 8-meter air muscle to do? What I wanted to do?
Oh, well, actually, it's a bit of a red herring, really. But can I just say, we did sell a hand to NASA, which, after their first hand, they bought one of ours to inspire their engineers. So their next hand, which was actually got a mission, was to some extent inspired by our hand. I don't know to what extent, but at least they did. That muscle, to be honest, was a bit of a red herring. The idea was that they wanted to have for docking spacecraft together, a huge bellows that could be contracted around the space hatches in space. And the air muscle was tested. I've got a photograph of it somewhere, this amazing, huge, full-scale test. Some of these air muscles wrapped around this gigantic, sort of 2 or 3 metre across bellows contraption. But that was it. Nothing came of it. So it's a bit of to be honest, probably shouldn't have been in there. It was you can't help mentioning it, you know.
Thank you. So might I ask a question? Robots have already begun to be used in warfare with the US military's Predator drone. Obviously this is still human controlled. Where do you see this eventually leading? Do you see the wars of the future being fought with robots? Or will there be wars?
I think it's inevitable that there's more and more automation in everything. Robots are just part of that. There will be more and more automation in warfare. There always has been, there always will be. There's one key issue, which is the question of a government such as the American government going to war with the promise to its people of no losses of their sons and daughters. And that, I think, is a very big moral issue, because it does enable a country to go to war much more easily if it can say to its people, look, we can go to war, there'll be no American casualties. Now, personally, I have a son. If he was to go to war, I would say, God's sake, no, I'd rather we had a robot than him going to war. If they're going to have wars, I don't want my son going to war, and no one wants their son or daughter going to war. Let's have robots do it. So, on the one hand. So I don't see anything particularly heinous about a drone shooting down people as against a plane with a person dropping bombs on people. How do you distinguish between these two horrible things? The important thing is to try to avoid the situation that brings them about. But, as I say, there is one worrying aspect, is that I think it does make it easier to go to war if you can say to your people, I promise you there'll be no American losses. They could start doing it everywhere. But I do think that the legged robots that have, I don't know how much you guys have been following it, but there's been tremendous successes, particularly with Boston Dynamics, and also been copied in Italy by ITT, the Italian Institute of Technology, who've also got a similar quadruped. But that to me is these are infantrymen, and I can see that infantry is what you want. You don't want to be sending infantrymen if you can avoid it, and so this to me is what it's all about.
Shanahan, would you like to add your thoughts?
Yeah, so I think in fact you don't need very sophisticated robot technology to make quite a scary weapon. I think that we already have the ability to make quite a scary robot weapon, because it's not very difficult to build a robot that can move around in an environment. It's not very difficult to build a robot that can simply recognise a human body. There are lots of ways of doing it. We can recognise faces very easily. There's a distinctive infrared profile to a human body. So it's not very difficult to pick them out using your sensors, and it's not at all difficult to make something that can automatically point a weapon at that thing. So I think the technology is very, very much within our grasp to build scary things that you can just drop somewhere and that will go around killing everything human that it can come across until it's given the stop decision. And that's a pretty scary thing. And whether the American military or any military is developing things like that, I don't know. But I'd be very surprised if they weren't. And maybe they're not. Maybe they wouldn't want to advertise it too widely. But that seems to me to be something that you could certainly do. Now, of course, the huge moral horror of that is that you're taking the kill decision out of the hands of humans. Once you drop that thing, I mean, it's like a bomb that goes off slowly and is constantly, taking these kill decisions by itself, and that's a horrific prospect. But possibly even, I don't know whether it's more or less horrific if you build in more intelligence to the thing, so that it applies some kind of reasoning process to decide whether or not to shoot its weapon at this particular human-shaped infrared profile on the basis of who knows what. But all of those things are actually not particularly sophisticated technology, I think. Yeah.
Would anyone else like to ask a question? The gentleman there.
Just to make a point on that, conventional warfare is fought by soldiers who are as good as their training and they're trusted. And I think with robotics, especially if you go with the bio-inspired control systems, you end up with a training problem rather than a programming problem in order to have good decisions. I actually have two questions. One for Murray, which is you've gone from GoFi and symbolic logic into wet reality as an inspiration, but what about machine learning? Do you get anything from that side? And also, if I might sort of follow on one for Richard, which is you're building machinery. What were you thinking would be controllable?
Okay, so machine learning, certainly machine learning is an area that has come on very substantially in the last decade. And we can envisage a kind of theoretical level at which the learning that goes on in the brain can be assimilated into a deeper theory of machine learning that applies, so that it applies both to the brain and to other kinds of artifacts we can build. And so that's certainly a fascinating prospect for the future. I think it would require a certain amount of theoretical development and greater empirical understanding of the brain for these two things to converge. Now, personally, I mean, maybe it's my problem, but I rather than segueing into an adjacent area that's not so far from symbolic AI, I decided to completely abandon it and move and start studying neuroscience, which is probably just a bit of craziness, but that's the personal path that I've taken. So I have to say that recent developments in machine learning it's not an area where the technical details I'm really terribly on top of.
I think there was a second question. Shanahan.
Yes, the question of who controls or in what way are the robots controlled, and the key word here I think is autonomy. interestingly, the DARPA challenge, which was a very interesting thing that came up about 6 or 9 months ago. I don't know if people have been following these DARPA challenges. Can you nod if you know what I mean by DARPA challenge? Okay. So, well, half you didn't. Some years ago, there was a DARPA challenge to drive a vehicle with no driver, and it was unexpected, to my view, unexpectedly successful. And within a few years, we had cars driving across the desert at high speed, avoiding obstacles, doing everything. And now we have them in traffic and so on and so forth. Now, DARPA issued another one, a very interesting challenge, around the turn of the year, which was they set up a sort of Chernobyl. No, sorry, not Chernobyl. Fukushima. I'm terrible on names. Situation where you may have noticed, and certainly all roboticists have noticed, that the robots were no use whatsoever in this disaster scenario. So DARPA said, right, we want someone to come up with a robot or robotic system that could deal with a sequence of problems in such a way as to be useful. And it was supposed to drive an ordinary vehicle, it was supposed to walk or get across rubble, climb ladders, go through, knock down walls, open doors, and replace machine parts, which I found extremely interesting challenge. Now, the question here was all about autonomy and teleoperation. And so they said, if any of the contestants try and do it all by teleoperation, we're going to arrange for interference, either physically interference through, if they're using wireless, then we're going to jam the wireless, because we don't want this whole thing teleoperated. But they are looking for, I can't remember the phrase now, some of you may know it, sort of managed pockets of autonomy within teleoperation. And I think that some people say that DARPA, because DARPA now, in my view, is the biggest driving force in robotics at this moment. And they are saying, actually, the physical side, the mechanical side is going well, mostly thanks to Boston Dynamics. But this whole question of autonomy is, of just sort of software in general, is the big open question. And so what I think I'm hearing is trying to get a robot just to be totally autonomous is, and you may disagree with this, but the idea of a robot for long periods of time in an unstructured environment being autonomous is pie in the sky. It's the same to my view. It's the same delusion as the whole humanoid idea. It's trying to play God, if you like. So I think what people are looking at they're saying, well, for instance, I mean the Asimo, I think, is the controller. The bipedal robot that Honda produced. If anyone doesn't know that. It does its walking, it obeys a set of rules, it is to some extent autonomy in terms of local decisions, and then you have someone giving high-level decisions by teleoperation. So really that probably is the general consensus, and then the question becomes really complicated when you start going into the detail of this. Now, personally, I have swung away from autonomy. I thought at the beginning, 20, 30 years ago, a robot's got to be autonomous, blah, blah. I'm interested in robots caring for people, doing stuff for people. I'm actually now going more and more and more towards actually the person controlling it more and more, maybe even towards 100%. But what I mean by control is the thing. So, for instance, if I want it to take the the Sunday roast out of the oven and carve it, I would like to be able to say, robot, see this bottle here, this is an ordinary bottle. As I move it across, would you open the door, take out the joint, put it down, and then as I move this cap across, I would like you to carve it. So I sit there and say, ready, go. I move it across, and then for some reason I decide to stop because I'm damn clever. And I see something, something happens, and I slow it down, I speed it up, I stop it. Now it's doing a huge amount of complex stuff, but I'm still the one, the top level brain that's in charge. Now this is me and a robot working together. And so then it gets it down there, and I say, okay, carve it. And I carve it according to this. And I move this cap. I've told it, it's got a vision system, it can see where the cap is, and it moves its knife backwards and forwards. And again, it starts to go wrong, and I can see. Or a child walks into the room. I mean, that's the sort of slightly extreme situation, but something like that. I'm not abrogating stuff. And the point is, I want these robots to really do stuff for people. Well, it's no use having the person sitting there in a chair with their hands on their lap, and the butler comes in and brings them their afternoon tea or stuff. I want them to get involved. And by the way, while I'm on this subject, which I will stop in a moment, instead of doing this, I'd like to be a bit cheeky and make them jump up and down a bit to do it, because I want to get everybody out of their chairs and moving around and stuff. So actually they may be around the oven, but the point is, whatever it is they can't quite do, the robot enables them to do. And it can be very complicated, and it will require some very advanced engineering and even more so software, but it's a long way away from autonomy.
Shanahan, do you have anything to add?
Just that I quite like the armchair vision, actually. Yes, I mean, my interests are somewhat different, but I think I share your sense of realism about what can be achieved in terms of autonomy in the foreseeable future. I'm a bit pessimistic. I'm likewise a bit pessimistic about what can be achieved, but I wouldn't call it pie in the sky. And I'm certainly open to the possibility that there'll be a substantial breakthrough, at any time that may lead us to understand, for example, the biological brain better, and that in turn will lead us to build something that really is autonomous. And in fact, if we look at, for example, a guide dog. I mean, a guide dog has a much smaller brain than a human being, but really can be pretty much trusted to do extraordinary things highly autonomously. And if I could understand the brain of a dog and could build something as sophisticated as a dog, and that was also as useful as a dog, then that would be a terrific achievement.
I think it's a good point.
Thank you. Does anyone else have any questions about the future of robotics? Josh?
Yeah, so an area that interests me is computer vision. And because, as I'm sure you're aware, a huge portion of the human brain is devoted to things to do with vision, either spatial perception or natural low-level processing of the information. And you were saying, Professor Shanahan, about the ground-up approach of looking, sort of getting rid of our ideas of logic and high-level programming, and sort of looking at something at a lower level. And I was wondering how your approach what your ideas are relative to human vision, because it's sort of one of the big stumbling blocks in biological brains that we need to solve.
Well, I leave it to my PhD students, like Richard down the front here. I mean, it's true that even if we look at very simple brain. So if we look at the brain of it's not a very simple brain, but a quite simple brain, like the brain of a rat or even a bee, then a substantial chunk of it is devoted to visual processing. And I think the question that interests me is, to what extent could we isolate the functionality of the visual cortex in a rat or a pigeon or something, and think of it as something that's separate from the rest of the brain, and think of it in the way as computer scientists, we think of things as a box that will provide, outputs to the rest of the brain, or is it something that is integrated like a plate of spaghetti, where you can't really divide it up in quite that way? And I think the answer to that question, which I don't know the answer to that question, but the answer to that question would if I knew it, then it would dictate what kind of approach I could take. Can I just ignore vision as a specific functionality and just study connectivity in neurons and their dynamics, or do I have to think about vision as something special? And I'm not quite sure. I mean, I think at the moment I'm ignoring vision as something special and thinking about neurons and the way they connect together as a substrate, and how that can work in an embodied setting with really a much simpler sensors in mind. Now that may be a mistake. I don't know.
Richard Greenhill, would you like to add any comments?
I don't have a lot to say about vision. I mean, I would say, looking at it just on a low-level point of view, the availability of the Kinect camera, if it's a camera, the Kinect system, to my view, has blown open the vision support system to everybody, because for £100 you can get something that used to cost a huge amount of money. It works on the basis of a light striper, which I tried to build years and years ago, like this, and it's not looking at colour or edge or a lot of the visual cues that we have. It's actually looking at the shape of surfaces, and I do think that's the way to do it. I think edge detection is a false friend. So I think there's a huge amount of work that we can do, and that that you guys can do. I mean, you can all sort of rush out and buy a Kinect system. You can. The software has been opened up. It used to be Microsoft, but now you can get it on Linux and so on. And it will key into ROS, which is the robot operating system that's become very common. And what it means is that for the first time, it's very easy to start understanding what things actually are. And this is the whole problem with vision. We've been able to do all sorts of fancy stuff with pixels, with grayscales, colour and so on, texture, but understanding what things are. Now, it's the route to understanding what things actually are from Kinect is very quick. It itself does, insofar as if you dance around in front of it, it has a model of your skeleton built into the software, and so it can start being predictive about your movements. So it really has, we can quibble about words, but I would call it an understanding that there's a human out there. And so when you're about to do something in relation to an object in the real world, it can quickly start taking decisions or giving information that can lead to decisions being taken. Is that, by the way, what's that? It's just a camera, is it? It's not a scanner. It looks a bit like a scanner. It can actually start saying that's dangerous, for instance, or that's good, or that's bad, which is an interesting whole domain. I don't know how much you want to go into this, but if I want this robot to look after old people and so on, we need to start having some values in there: sharp, dangerous, and good, bad. We get into things like Asimov's 3 or 4 laws and so on quite quickly. Well, what I'm saying is that the light striping, this 3D camera takes you quite quickly into areas where you know that this is a person, you know that this is a knife, you know that this is hot water. And the question is, and to some extent I avoid it with what I said earlier about having the person in charge. But one of the big problems is safety. If I'm going to inflict my robot system on millions and millions of old people, how can I guarantee it's going to be safe? So maybe what I'll have to do is, even though I will have humans very much at the top level of control, I'm going to have a policeman in there, a police person in there, which says, that's not going to happen. And that is an interesting one, whereby you track with your vision system all the objects, all the participants, and if there's a baby, if there's water, if there's electricity, all these things, you have rules. And you say the risk, and you probably have a whole lot of stuff, you have some sort of rule sets which give higher values of danger in certain situations and speed and so on and so forth. So, whereas on the one hand I've been arguing for humans in control, these things have got to be safe, and this is the biggest problem. I said cheap and safe. That's what I want. And safe involves vision systems very much, or ways of knowing what things really are and what they. Obviously, then you have a list of attributes of what they're capable of doing. Sorry, long answer.
Anyone else? The man in the black striped top.
It's more a question for the second speaker, actually. It's a couple of questions, really. Firstly, when you say that you go back to the brain to start to understand how the neurons connect, to then go on to try and replicate this in artificial intelligence, does that necessarily mean that the wiring in the brain is the best way to do it? Or could sort of representing sort of models of cognition be done more simply, actually to the same effect in artificial intelligence? Is the sort of first question. And the second question from that is, if it's not, and you do, and the only way to replicate this would be to replicate the complexity of the brain, what are your opinions on how actually achievable, given an infinite number of years, that is?
Yeah. Okay. So I think it's in pursuing the kind of methodology that I'm interested in, the sort of brain-inspired methodology, and in fact, just in general, to understand the brain actually in neuroscience itself as a really big aim. An absolutely fundamental question, I think, is what is the level of description at which the kind of perfect theory will be written, right? So for example, does it actually, and this is just in a sense just repeating your question actually, so does it really matter what goes on at the quantum level, or does it really matter within neurons exactly what the electrochemical processes are for synaptic transmission of signals, or can you abstract away from that into some mathematical model and abstract away from it? And so that's just as I say, it's just repeating your question. I don't really know the answer, and it certainly could turn out to be the case that we can abstract away from neurons altogether, from spiking neurons altogether, and we can instead represent everything that's going on in a large number of spiking neurons with a dramatically smaller number of equations that describe a sort of field theory of the brain. So people have been looking at that kind of thing, and maybe that's the right level of description. And I don't think anybody really knows the answer to that yet. What will, when the Einstein of the brain or the Darwin of the brain comes up with the grand theory, which there's no sign of that happening just yet, what language will it be written in? And but I've got my personal hunch, right? So if you want to know what my personal hunch is, I don't think that quantum mechanics matters. So if you're familiar with the ideas of Roger Penrose, I personally don't see that the kinds of quantum effects that he thinks are important for human level intelligence. I'm just not convinced by those arguments. I also suspect that you can abstract away from a lot of the electrochemical details of what's going on at the level of, say, of synaptic transmission and so on. But I suspect that maybe you cannot go above the spiking neuron. So most of my research these days that's the level at which I stop. So I simulate spiking neurons. So I'm interested in spike events. So as many of you might know, what essentially a neuron does is it's like a little capacitor which charges up, the membrane potential increases until it reaches a kind of threshold, then it emits a spike of electricity along its axon. And it's those spikes which can have very rich timing properties that really do everything in the brain. Well, that's what I suspect is the case. So I think that that's the level at which things matter. I suspect that maybe you can't get simpler than that. So you can't abstract away from individual spikes and still get the level of rich dynamical complexity that you need to produce human level or even sophisticated animal level cognition and behavior. That's my hunch, but it might be wrong. Just can I add one more little point to that? So I also suspect that if you could abstract away from that, then nature would have found a way to simplify things in evolution, and so that's a kind of argument, I guess.
Man at the back.
This is for the first speaker. So you kind of dismissed the idea of a fully autonomous humanoid robot. What do you think is the future for, say, are the prospects for, say, robotic prostheses or human-assisted devices like exoskeletons? Could you see these being the way of the future for the care of the elderly that you talked about?
Yeah, I mean, both. I think those. I see a smooth path forward for prostheses. I think they should just get better as the technology gets better. There's no particular problems, gotchas. Exoskeletons are quite difficult. And there's a whole area of force feedback control, which is really difficult. Now, if I want to have a robot arm, we've conveniently got two of these dusters. And if I want to be over here, and I want to remotely control, teleoperate my robot to pick up this one. Sorry, I'll put that down there. I could have a camera. I've got a robot arm there, and I've got an exoskeleton or something so that I can control it, and I move it down.
I'll be the other robot.
You be the slave. I was wondering if you would. Yes, okay. You're the slave robot,
okay.
And you follow me, and I make you go a bit to the left. I make you go down. I make you close your fingers, and then I make it come up. Thank you. That's great. Now, exactly. Now, everybody, after they think about it a bit, would say, okay, but if you're doing something difficult, wouldn't it be good if your exoskeleton could give you some force feedback? So in other words, as the robot arm fingers touch, you have something that tells you, that makes you, emulates the feeling of touch. As the robot arm lifts the heavy weight, you have something that emulates the feeling of heavy weight, because it's jolly hard to do complex things without any sort of feedback. And this is a kind of the holy grail, in my view, of mechanics in robotics. Probably the second of those is easier, to apply general force to give you the impression that you're lifting a weight or that you're meeting a resistance of some sort. But what about your fingers? Now, at Shadow, we've had nightmares. For years and years and years, we've designed touch sensors which go on the robot hand, and we've had a lot of problems with it, but I won't go into. But really, what you want is those touch sensors to, in some way, give you the feeling that you've touched something. Now, it's been done some years ago. There's a thing called a phantom, and what a phantom does is the robot hand could just take one pointer, and it could go like this and explore the shape, And you can be holding a remote equivalent, a stylus, and it's very clever. Every time that the one in the robot touches something, your stylus stops dead. And it's done all with clutches, because what you're actually holding is something that's on the end of some sort of mechanism. And as it touches where it believes there's a surface, it suddenly stops dead, and you can push it and tap it and so on. So that's been done for single point explorations. What I would love to do is to have multiple, so that the whole hand, as your finger closed around this, which has got some soft bits and some curved bits and so on, I would like to emulate that same sense of touch and put it back into the fingers. And I say it's a holy grail because it's the question. You're never going to succeed with everything. You're never going to make it so that whether it was wet or dry, slippery, rough, convex, concave, etc., etc. And in fact, you're really going to always find that your customers are pretty disappointed because they're going to pay a huge amount of money for this thing, and it's only going to do half the stuff. So there, if anyone wants a really, really big challenge, it's just a question of how to actually do it mechanically. I've got some ideas, but the chances are it'd be very expensive. What was the question?
What were the obstacles?
Obstacles, yes. So teleoperation, my feeling is it would be a lot easier if you just did it sort of bit by bit and you had single problem solutions. You say, I want to pull the plug out of the wall or something like that. And you just solve that problem rather than trying to do it the big one. Now, I can imagine myself in 15 years' time sitting in my bed or my chair or something, pulling lots of bits of string actually, or something like that, little funny handles, and saying, I want this to be the something or other now, and this to be something, and teleoperating in that way. And having some vision and so on, but basically coming back all the time to the human, because it's just, I've just found everything to do with pure robotics, if you like. The thing I started off with, the humanoid and autonomy and so on, is just so hard, and everyone else seems to be finding it hard. I mean, you're more or less saying that you agree. It is just so bloody hard. Yes. So, and I mean, yes, that's right. You asked about exoskeleton. The problem about exoskeletons is how big and clunky. That there is one in America, can't remember the name of the company now, but they've got soldiers lifting heavy things and loading them. But what I would do, my answer to the exoskeleton is the helping hand. I mentioned it here. You don't have a whole thing, so you don't get into anything, you're not strapped in or anything. But when you want to do something that's a bit difficult, this thing just comes along and guides you. I had an interesting experience with my grandson, where when he was really only 1 year, and I was at the wash basin, and he didn't quite understand about the taps and the hot tap and the cold tap and so on, but he realised that if he pushed my hand over to the hot tap, I would turn it on. And if he pushed it over the cold tap, I would turn it on. And if he pushed it over the soap, I'd pick it up. And he began pushing me, and he wanted to play around with the water. He was able to push, pull, push, pull, push, pull. I think this is an interesting way of using our joint intelligences of what I was just making available to him low-level skills. He was using his very limited high-level skills. That mix, that symbiosis between robot and person is really what I'm interested in. And I think that we can really make stuff that really will do what we need that way, and that going towards the butler, humanoid, autonomous are all dangerous paths. Okay.
Thank you very much.
Regarding that, how could nanotechnology boost the exoskeleton?
Sorry?
How could nanotechnology boost the progress of exoskeleton?
I don't know much about nanotechnology, but I suspect it could if we're talking about the fingertip.
Yes.
Yes, if we want lots of little mechanisms that are cheap, and so you could actually have little mechanisms pressing against your fingertips, emulating touch, nanotechnology would be a way to go. Can I say there's been a gentleman in the corner who's put his hand up every time and never been
I was about
spotted.
to pick him next time. Actually.
Oh, sorry.
So would you like to ask a question?
Yeah, what I want to ask is about the title of this talk, future.
Yes.
Because I want to know what is going to happen in 30 years' time, 60 years' time, 90 years' time, 3 generations.
60 and 90 years' time?
Yeah, 3 years of time. Yeah, we very interested in the kind of milestone, what is happening in the laboratory and what is happening in the industry or society. So I'm interested not about today or the year past,
No.
but what will be happening.
I don't know. I'm thinking about 15 years' time. Probably what I'm thinking about will take more than that, because in my experience, whatever you say, it takes much longer. Can I ask you, are you thinking about... I mean, when people talk about the future in robotics, sometimes they're talking about the problem of robots taking over. Is that at all what you're...
No, I'm interested about the technology side, not about the society, because society is being moved by the economy or
okay.
That's what the technology was.
Okay, well, I would suspect that we at Shadow we started off using air muscles, and we've, for various reasons, moved towards using motors. I'm now thinking of moving back to air muscles more and more. And I think that if we could find something that emulated human muscles better, one of the problems with air muscles is the very simple thing that you need compressed air, and it's not very convenient. If someone in this room could invent a nice little compressor that's silent and produces, not a lot, but enough air to move some muscles, that'd be great. People have been playing around with, I can't remember what they're even called now, the electrical charged polymer muscles, and I don't think they've got very far with them. But presumably, eventually, they will find a way of making some bundles of fibres that do contract. So I suppose that's what I'd expect in 60 or 100 years' time. I'd expect real muscles. Do I want real muscles? In a way, you see, I'm looking now to industrialise the home rather than making things like nature. I mean, yeah, borrowing from nature all the time, but not centred on that. My future home would probably be not acceptable to most people at this moment, and I'm relying on the fact that, or I'm relying on the idea that people will get used to it with time, and that they will be happy to have all sorts of gizmos attached to the ceiling, looking more like this. And that's why I call it the industrialisation, because industry is brilliant. It can do anything, can't it? In these factories, they can make anything. I want the same thing in my home. When I lose the power of my body, I'm thinking of something that's looking more like machines and not looking like pretend human beings. But to be honest, I really struggle to think 60 or 100 years. I think I ought to be honest and say I haven't got a clue.
Oh, so do I get a go then? So, I think it's very difficult to put numbers on these kinds of things in terms of years when we look ahead. But if you ask about what would be possible in 100 years, 1,000 years, and so on, then I suspect that within my lifetime, it may well be the case that we don't achieve anything like the kind of vision of AI that I saw in the science fiction that inspired me as a boy. So I'm not sure if we'll get Sonny the robot from iRobot coming about within the next 10, 20, 30, 40 years. Maybe we will, maybe we won't. However, if you want to just extend this horizon by many, many decades, then in 100 years' time, I would be very surprised if we hadn't achieved that kind of thing. And seeing as my children, or at least my children's children, may well be around in 100 years' time, then this isn't completely irrelevant to me or to us. And I suspect that will. Your question was about the technology, not society, but I think that this does have the potential to very dramatically affect our society. One thing that I think we do tend, one lesson about the future from the past is that it never turns out quite the way it looks in science fiction films. We tend to think that the science fiction vision is of lots of robots that are like us, wandering around, or look a bit like Arnold Schwarzenegger, or maybe nicer versions thereof. But it may well be that the boundary between humans and machines, between biology and the synthetic, becomes a lot more blurred, and we find that there's people talk a lot about cognitive enhancements, about neural prostheses, and we can imagine at the same time that our environment becomes more and more immersively technologified. Than it is at the moment. That we find technology just embedded in us in the man-made environment, just absolutely everywhere. When you put those two things together, then it's actually quite difficult to envisage exactly what what things would be like in 100 years' time. But I do very strongly suspect that that human-level AI will have been achieved by that time, and I think that will affect all of that very dramatically, and who knows how.
Thank you very much. Gentleman there on the break, please.
So it's Murray. So how do you foresee getting over the problem of training? So even if we could make a model of the brain, or we understood enough about the brain to make the baby, it's not very useful for a few years. And people have to invest a lot of time in training. They might not be willing to do that.
Yeah. Yeah. Okay. So again, if you're allowing me to speculate somewhat, then this is a case where if you want to go, there's two ways of tackling this problem. One is, of course, if we allow ourselves to use virtual environments. So if you imagine that you build a physics-based simulation and you have you use that for your environment and you use that for your robot as well, then of course you can run it in hyper real time. So you can collapse 20 years of training into 10 minutes, right? So you can run it like that. So that would be one way of addressing this problem. And also, of course, if you've built the thing about digital technology is once you've done it once, you can just kind of copy it. Now, I think in reality things are a little bit more complicated than that, because even in digital technology, every time you train even a simple neural network, it's different every time, and it depends upon the environment that it was trained in and so on. So it's not quite as straightforward as that, perhaps. But you can suppose that you've got something that you've trained up to a certain level to handle an environment of commonplace objects and so on. Then you don't have to do that again. You can just take what you've got and just plug it in. Load it up and go. So there are two things there. One is simulation in hyper real time, and the other is the fact that with digital technology you can just kind of make as many new copies instantly as you like.
Would you like to add anything, Richard?
No, I agree, really.
Yep.
I would like to ask that. If we have a different approach to the development of an artificial intelligence, instead of starting to replicate a complex structure such as the brain. So this approach would be to replicate in a software manner the DNA and allow the software to build itself. At a certain point, the artificial intelligence would be able to create its own hardware, at a certain point. But the beginning would be the same way a child is born, starting from a single cell to a very complex organism. If we could emulate in software this single cell and allow it to grow by itself, we could reach a point in which the software creates its own hardware. So, is that a good approach?
Yeah, I think it's an extremely interesting approach, and as you probably know, there's a whole field of so-called evolutionary robotics, which has been around since the 1990s. The aim of which is to use genetic algorithms to evolve controllers for robots. Now, now in evolutionary robotics, which again you can do in simulation or you can do with real robots, but either way, the tendency has always been to take the robot body for granted, and what changes, the genome that changes during the evolutionary process is just the thing that it describes the controller. So that's all that changes. But there's absolutely no reason why it shouldn't actually describe the morphology, the shape of the robot's body as well. And and for sure, those kinds of experiments, very preliminary versions of that kind of approach to evolutionary robotics, has been taken before. But as you can imagine, it's very computationally demanding if you want to actually simulate the whole development process of the growth of a body, and then you want to put that in an evolutionary setting. So then you're going to simulate a whole population of these things, growing and then behaving in the simulated environment. So that's put a limit on really how feasible this kind of approach has been up to now. But I don't see why. I think it's a good idea. And certainly, if you take that whole Brooks way of thinking, I keep on referring to Rob Brooks. So if you take that whole way of thinking seriously, then you shouldn't start with the body fully formed. You have to take into account the developmental process as well, because that's very important. Yeah.
And it's easier to emulate the single cell rather than a complex structure.
Well, I guess it is. Yes, I guess it is. And and probably what you have in mind is that you don't have to simulate single cells that are like biological cells, but rather what you can do is simulate a kind of building block which you can assemble in different ways in a virtual environment. Then you can imagine you can assemble these building blocks into bodies in all kinds of ways which you couldn't do in reality, and that's potentially quite interesting.
No, I was saying that
you want to simulate the real cells.
The real cells.
Yeah, so certainly, yeah.
And the cell would evolve by itself, would multiply.
Yeah, certainly you could do that too, and of course the more biological, in principle, but the more biological realism you want to put into simulating your individual cell, then your computation required to do this, very rapidly blows up. But and whether Moore's law will always help us out here, I think, I don't know, but I suspect that it will level off before it really helps us out with this kind of approach. But I'm not sure.
Sorry, could I ask you to set questions for the session afterwards? Is that a question for you guys?
I had a question for the first speaker this time. Sort of picking my words carefully, and correct me if I'm wrong, because I don't mean to be disrespectful or anything, but the impression I get from your description of this sort of like old person's house you're describing, it sounds a bit like a sort of a product line where you wake up in the morning and you sort of go around on a conveyor belt, and there's a sort of a kitchen bit that helps you and a bath bit that helps you and whatever. And I was just wondering if that was in fact sort of the way you imagine it, at least initially, or whether or not, or sort of how much flexibility you think you could provide in that situation for people just to do stuff throughout the day, rather than just things that happen in the kitchen and things that happen in the bathroom and sort of more sort of hobby stuff, or just more sort of flexible.
Oh yes, the creative stuff. I think really being creative is probably the most fun thing in life. So I want everyone to have fun. If I'm going to perpetuate life, which is what I want to do, extend life into old age, above all, it's got to be fun. And so that means, variety, choice, and so on and so forth. But there is an I don't know if you know Emmett. Does that mean that it used to be well known? But sort of bits of string, and there was this guy some time ago that built all sorts of contraptions, and the sort of ball would roll along and land, and it would break the egg, and then it would something, and the teapot comes up, and you know what I mean? A Wallace and Gromit, if you like. Wallace and Gromit. There you are. I have to admit that I think it's going to be like that. All right? So the next thing is, there's two things. One is, I've stopped caring if anyone else wants it. Because you can just go bananas trying to second guess what people will want. And our patent advisor, who's got 15 years advantage on me, he's 85, he says, listen, people, when they get to that stage, if it's down the road to the old people's home, or if it's having fun, because you're going to have fun in this place, and being stimulated and independent, and when you want to go to the lavatory, you go to the lavatory. That's probably almost the biggest single thing in all this. A few bits of string and a bit of Wallace and Gromit stuff will be all right. But the trick is, what you have to do is, and I've heard this from going to meetings about AAL, ambient assisted living, which is kind of talking about this. You've got to make everything aspirational. And the icon that's held up, which you don't remember, is National Health glasses that used to have pink frames. And if your child at school had these National Health glasses, everybody knew they were no good. And so what the new icon is the iPad, which everybody loves. And the president of the Age UK said to me, of course the iPad is principally designed for old people, which I thought was interesting. But it's aspirational. Everyone likes it. Because an old person has an iPad, no one thinks, oh, you're a doddery old twit. So the trick is, all the stuff we produce, we've got to make all the kids on the block want to borrow it and play with it. Okay, that's not so hard. Segways and, think, who wouldn't... We can make stuff exciting, but it will have this quality, in my view, of the Wallace and Gromit stuff. And I want to say, yeah, I'm not going to be a suave, humanoid, cool, like in iRobot, who can do everything. I looked at that guy. By the way, he's got shadow air muscles. Did you see? Straight off our website. I can tell you the pictures. They copied them off. We should have got paid for that. Anyway, it runs around. It does all these things, and that is what I'm saying. No, I'm turning my back on that. I'm going for the Wallace and Gromit version, and then we're going to make it good for me. And I think what's good for me, there'll be quite a few other people who will say, actually, I want to live at home. I want to be active, healthy, have fantastic sports, great sex. Did I mention that? All this stuff, on and on and on and on. And I don't care about a few bits of string and sealing wax.
I think we have probably time for one last question. Yep, the guy in the centre.
I'm very interested in motor control, and after all, lots of interest in robotics is robots can move. But I find that the robots does not move like human, and this is a big topic. Over the years, some people say that robots does not move like human because the mechanics are different. Because if you have something like muscles, maybe you can pick up an egg more easily. If you have a stiff hand, it will cost you a lot of thinking to pick up an egg. And where other people say that just because we are more clever and we can solve lots of complex dynamic problems. And it turns out that it seems like our brain only allocate a small portion to model control, and this is most important for our lab. So I want to ask you too about your opinion. It is because we move more easily because we are stupid, but we have a more smart machine, mechanical structure, or because we are just smarter, we can move with a very, very simple structure. So that's my question.
I don't know much about motor control. I have tended to concentrate on mechanical systems and having them compliant. So the egg that you saw, that is the air muscle hand, and it is easier with air muscles because of this compliance. And now this is being done with the series elastic actuators, which is a motor, a gearbox, and then a spring. And it just it fudges the issue, really. Now, people are improving motor control more and more, and the shadow motor-driven hand is pretty amazingly good, but it's extremely hard. And I don't know anything about the algorithms that they use for the feedback loops to get good control. And they will get better, but this is a sophisticated side of robotics, and I have to admit that I don't know much about it. I am very much the other end, away from the sophisticated end. I'm not sure if I've answered your question, really.
So one point that you made about not very much of the brain being devoted to motor control proportionally, but in fact, as maybe you know, the cerebellum, which is the little kind of like bit that hangs off the back of the brain, actually contains 80% of the brain's neurons, which is an astonishing fact. So in the human brain, about 100 billion neurons, about 80 billion of them are in your cerebellum, and that cerebellum is predominantly implicated in fine, motor control, but it's one of those bits that you can damage quite severely, and the person is still there. Whereas if you damage the cortex, then of course the person may still be there, but it affects their cognition or their perception very, very, very. Very soon. So in fact, there does seem to be, there is quite a lot of the brain that's devoted to being clever for motor control, to use your terms. But on the other hand, I don't know if you're familiar with these passive walkers. So I mean, you can't help being impressed. So passive walkers are completely mechanical systems which just is basically a pair of wooden legs, which is very cleverly constructed. The mechanics is very cleverly constructed so that you can just take this pair of legs and put it on a slope, and you just tilt the slope, and it will walk like, and it looks completely like a human being walking down the slope, just a pair of legs. And there's absolutely no control there at all. That's the sense in which it's passive, and it's relying entirely on the natural dynamics and mechanics that's just in that little structure. So that goes to show, on the other hand, that you can get an awful lot of cleverness out of just the shape and just the mechanics. So I would imagine that nature, of course, is going to exploit both. Is going to exploit that as much as it possibly can. So it's going to get as much as it possibly can out of natural dynamics and mechanics and kinematics. But on top of that, it's built, some pretty serious computation into this cerebellum of your brain to do lots of extra stuff. So I would imagine there's a combination of that to get a really sophisticated sensory motor control.
Sorry, we have a bit more time before the reception is actually ready. So, does anyone else have any questions? One more from Josh there.
So, this is maybe coming back to things you already dismissed about humanoid robots, but they're an area that interests me as well. And so, there's lots of limiting factors to why we can't do them right now, and there's maybe limiting factors for why we can never do them. But based on the sort of contrary areas you guys come from, sort of from the mechanics and sort of hardware side and the AI side, what things make us better than perhaps we could manufacture? Is it because our muscles are better and our mechanics are better and our feedback loops are better, or is it because that we've got better software to control relatively? It's maybe quite similar to this last question, I think.
Yeah, I guess it is a similar question, but expanding it into a bigger domain. And I have to say that I think it's the software that really counts eventually, because there's only so much you can do with a passive walker, and if we look at the animal kingdom as a whole, we're not really terribly different from most of the rest of the animal kingdom in terms of our mechanics and kinematics and so on. But what is different is what's up here, and what's different also between the smartest animals and the stupidest animals. So if you take a very smart non-human animal like a crow or a chimpanzee, and can you compare that to a less, it's always difficult to talk about greater and lesser intelligence. If you talk to people who work in these areas, they'll always argue about that. But an ant or something, then again, what makes the difference is what's up here, is what's there in the brain. So I think that's really where it's at. And I imagine that within robotics we will, and people like the shadow company and industry, I think, although maybe you're not moving in this direction so much anymore, but people like Boston Dynamics, that I think they will crack the mechanics before too long, and then it'll be all about getting the software to work right, whether it's brain inspired or whether it's engineered in from scratch. I'm not, who knows how that race will be won, but that's where I think it'll be at eventually.
Yeah, I mean, I suppose if you, going back to the question at the back, if you do look forward 60 years or 100 years or more, then maybe I would concede that someone who is a robot constructed just like us might eventually be able to do more or less everything we can do. I think I just feel more now, looking at the size of the problem, looking at the rate of progress. I've been in it since about 1980, so that's, excuse me, little maths, 32 years. Progress has been abysmal, in my view, towards what I used to call real robots. A robot in the sort of science fiction idea. That's what I started to do. And I now think the problem is just so big. We cannot, in my view, conceive of how clever we are. If you actually were to give someone instructions, get up in the morning and have someone take instructions about everything you do throughout the day and how you do it, and the references, if you would track your mental references back, and also how much you actually innovate. You see, innovation is a very interesting one. When are we going to be able to make cognitive systems that can innovate, or what? Perhaps the question is, what do you call innovation? But it's just so daunting. And what finishes it for me is that if I want it, I'm particularly interested in this one domain of the idea of it looking after people who are unable to look after themselves, which after all, for God's sake, is the quintessence of a robot in a sense. If your body's gone wrong, you want to create something that will help you deal with that problem of your body and your mind, by the way. We haven't mentioned this, but dementia is a massive problem for old people. In fact, statistically, it's a bigger problem than physical disability for old people. I want my robot to talk to me the whole time and prevent me from going nuts. And the way it will do it is by understanding what I'm doing, whatever understanding means, but in some way, understanding what I'm doing, helping me while I'm doing, being on the internet and having all the access to all the knowledge, and then it will be my secretary, and it will say, you haven't brushed your teeth yet. No, that's the toothpaste, that's the toothbrush. I'm exaggerating a bit, but I think it could coach you on and on and on. And I've gone a bit drift off your question. Whether a what do you call it? A facsimile of the human body can do this. Well, I mean, maybe, but look, I don't think in 60 years, I don't think in 120 years, I think maybe in 300, 400 years. It's such a big problem. And it's just, let's go on, we can do it the other way. Why don't we just go on and do it? Why don't we make robots that can do stuff for us? They've done it in industry, they're doing it in war, they're doing it in medicine, and they're saying, well, this is something that a robot can do, and so on. And so from my view, the way forward for the domestic robot is what I've said, because of that. And maybe eventually it could be done the other way.
Yeah, yes. Thank you ever so much. Would you care to make a quick closing statement each?
Quick closing statement.
Optional, of course.
Gosh, that's far too difficult. I haven't got a quick closing statement in mind. Sorry.
Okay.
Can I ask a closing question?
Yes, you could.
How interested are you guys in doing something to bring the future? Yeah?
Yes, especially. That's why they're here.
That's why they're here. Well, that's why I was brave enough to ask the question, because I would like to get some crowdsourcing. I mean, I'm very impressed by the way that Wikipedia, I mean, isn't that amazing, Wikipedia? Unbelievable. It's only, I don't know, how long has it been going? It's only 5 years. It's nothing. And we've got this incredible thing that has been produced by the people of the world. I think that's wonderful. Now, in a sense, a problem like the domestic robot, the robot looking after real people, as I say, row after row, street after street, it needs a huge input from lots of people. I would like to think of, one of the forms of teleoperation might be that when you have something, you just put out a call onto the internet in some way. You say, could anybody help me boil an egg or something, whatever it is, and lo and behold, your friend over here or machines start to grind into action, and they're being controlled by crowdsourcing. People who know about this, people who know about that, and this is all melded together in a magical way. Magic, I'm saying, because it's not trivial. So I'm saying to you guys, perhaps if someone would be an intermediary, because I can't actually deal with emails from lots of people, but I would love to know if there was would be an interest in taking forward some projects, perhaps starting not right today, but starting in a little while and going forward over a period of a year or two, whether people would be interested in doing stuff, because I think the future is there to be built. And what I'm saying is it's easy, easy-ish. It's not impossible, and it's unspeakably exciting.
I've got my future.
Definitely be interested. Yes, sorry.
So I've got my concluding statement.
Very good.
I've had time to think of it. So yeah, so my concluding statement is simply that the future will not be as we expect it to be, and that's it really. Unless you're William Gibson, but he's not in the audience. So.
Yes, thank you ever so much. I've definitely found it very interesting. So, round of applause for our guest speakers.